Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Active Sunspot Region 4366 Crosses the Sun. So, what do we see here? Well, here we see an image of our own sun, and we're seeing sunspots on it. Now, sunspots are darker regions on the surface of the sun. They're actually relatively cooler regions, not cold by any sense. In fact, they are still very hot, and if you could take that material out and put it out away from the sun, it would glow a reddish-orange color. But they are 1,000 or 1,500 degrees cooler than the sun, and therefore they look darker against its surface. Now, the first documented observation of sunspots was by Galileo in the early 1600s, when he used a telescope to be able to see sunspots on the sun and see that it was imperfect, that it was not just the smooth sphere. However, there's the possibility that they have been seen earlier than that. In fact, very large sunspot groups could be seen even without a telescope. And that could be done not normally during the day. The sun is far too bright. You can't see anything at that point, and it would overwhelm the darkness of the spot. However, at sunrise or sunset, you would be able to do this. And there are recorded observations that may show this from Chinese astronomers about nearly 2,500 years ago that recorded markings on the sun. Of course, we don't know exactly what they saw, but it's possible that sunspots like this were seen thousands of years ago. Now, an active sunspot region like this can affect Earth, especially when it is pointing in the direction of Earth. These sunspot regions are associated with the most intense solar activity, and in fact, this may be the largest sunspot grouping of this solar cycle. And when they do, they give off solar flares, coronal mass ejections, material that can be expelled out into space, and as it travels to Earth, if it happens to be directed toward Earth, can affect us here. It can affect us in many ways. A minor hit can give us beautiful aurora and particles that are striking our atmosphere focused by the magnetic field of Earth. An even more intense one, like a coronal mass ejection, could actually damage electronics here on Earth. That it could be enough to overwhelm Earth's magnetic field and cause damage to communication satellites or other electronics here on Earth. Now, how much damage could be done? Well, we honestly don't know, because it depends on the intensity of the storm. The last time this happened was back in the 1850s, so electronics were not a thing at that point, so we don't really know how much damage would be done. We do know that at that point, a large coronal mass ejection did cause problems with the telegraph and actually started fires by inducing electrical currents into the telegraph wires. So it's possible that damage could occur and then even more damage now with electronic equipment that could be completely fried if it is not well shielded from a large emission from the sun. However, this is now rotating and moving off towards the limb of the sun, no longer pointing in Earth's direction, and the question will be whether it survives a full solar rotation, which means we have about 2 weeks to wait for it to pass around the far side of the sun and then come back. Sunspots can last a few weeks to a month or more, so it's possible that we will be able to see this same sunspot region again in a few weeks, and we will watch to see what it does that time. So that was our picture of the day, titled Active Sunspot Region 4366 Crosses the Sun. We'll be back again tomorrow for the next picture, previewed to be Groovy Miranda. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.